Nice. Hey guys, thanks for joining in. Um, I'm here with Alex as well, and you will hear him in the background. We are doing like a remote session as well there. So, yeah, thanks for joining us. First of all, whoops, 1 second. Just changing my screen. So we wanted to do this live streaming session to give everyone the opportunity to see how we create a style and program shaders in Flair, and to answer also any questions that you may have, right? So please, if you have any questions, write them in the comments and we'll do everything to answer them, all right, to the best of our knowledge live. So for this session, I was preparing this character here, which is like an anime character. And we decided we've been postponing outlines for far too long, so why not, now that we have Flair, create a style that not only provides outlines, but also allows you to control the intensity and the thickness of outlines here with all of you guys. So if you have any questions along the way, please send them our way, and we'd be happy to answer them. So yeah, this is Maya here. This is Flair. Whoops. And as you can see, we have the live link between Flair and Maya, so they can communicate in real time. And this is a model that we bought from Sketchfab. So as you know, back in Flair, we have access to different types of data from Flair. Second. Let me just, so this is the AOV target. I need to add a light in here. We have the color target here. So with that being said, we're going to to create outlines, we need to first detect them, right? And we're going to use difference of Gaussians. There's other ways to do this as well, with like a subtle filter or things like that. But first, to do this, we're going to create an image shader node. And then we're going to load up an existing shader here. If I go to Edge, for example, edge detection, difference of Gaussians. This is like already within Flair. If I apply this here, you will see that we have some edges detected here already. Let me amplify this a little bit so that you can see this better. So I'm going to create another shader node, and I'm going to add a transform. Nope, it's not here. Blend alpha. Alex, do you remember where's the math, the addition shader?
Sorry, I didn't
As here, add. I just wanted to add this. So we can add, or we can
add.
Yes, maybe with this. Yes, we have an add multiplier. That's perfect. So what I'm going to do is I'm going to create here a black color, and I'm going to add the this edge detection that we just did, and I'm going to output it. And I'm going to do this one, increase the multiplier, so that you can see the first edges appearing on this character. Now, in this case, the shader that we are using here is fixed, right? So it's a Gaussian weight, so it's just a 5x5 kernel that allows us to create these outlines here. Now, I'm not sure, do you guys know how to difference of Gaussians works? How this kind of edge detection can be made? Anyway, so I think we have a slight delay, but I'm gonna create an image shader, and I'm gonna explain a little bit how this works. So we can here come and use the blur node and use one of these blurs here. Oops. So we have three different blurs. We have the box blur, the Gaussian blur, and an RI underscore Gaussian blur. This RI underscore Gaussian blur is a resolution independent Gaussian blur. And this is something that would be great to address in this video as well. So once we load up the resolution independent Gaussian blur, we can then input the color, then output it here as an output. And we here define what kind of blur, in which direction we want this blur to be. So if I increase here the radius, you can see we're blurring horizontally, or you can also blur vertically. So in order to have like an even blur, we're gonna do both. We're gonna do first horizontally. I'm gonna do 3 for now, and I'm gonna copy and paste this node and blur the same thing vertically. Now what we have here is a separable blur, so it's one blur done in two different passes, right? One horizontal and one vertical one. And we can define, if we were to define this like as 20 and 20, we would have a Gaussian blur of 20 pixels in every direction.
Let's rename the nodes so that we.
Oh yeah, so that we
can see.
So this is the
as a default
blur
names,
horizontal.
Just generic.
Yeah, in the future the names will be based on the shader, so it's going to be a bit more automated. But for now we need to work like this, and I'm gonna do 3. And the way the difference of Gaussians work is that you need to subtract one image, like the blurred image, from the normal image, and this will give you the edges of it. So let's do that. I'm just using currently shaders that we have already pre-programmed, but we're also gonna program some of these shaders as well with Alex here. So I'm going to go into, I'm gonna use the let me check this one. Here yeah. So this is a shader that we already have that accepts an input, right? And then the blurred input, and then it outputs the difference of Gaussians. This comes from the watercolor, so I'm not entirely sure this is going to work in this example, but let's try it out. So the blurred image here, and the not blurred image here, and then we put this out, and there we have some initial outlines. Now these outlines are entirely based on color in this case. There's no depth information yet because we have not added any depth information. We can, however, do that as well. So we can come here.
We do the color on the results.
Ah, the colors? Oh, yes. Correct. So that is set by the shader itself. In this case, so in this case, it doesn't really, the color doesn't really make sense because we expect an LAB depth image to come in, and we just plugged in the color, which is not the same. But we can actually also do that. Let's first bring in some depth. So we're going to use the AOV target. And when we visualize the AOV target, I'm just creating an image output here. But well, I'm gonna name this as well so that we know what node is going where. So this is gonna be the AOV target. And if we open here the render output, we see the original AOV target. Now, something that I have also noticed is that, yes, I was getting confused why we're not getting the right data here. And that is because we are using Maya materials and not MNPRX materials. So let me do something very quickly to transform this into MNPRX materials, and maybe that also gives you some ideas on how you can just load up your own assets with Maya materials and convert them in such a way that you can process them in MNPRX. So I've done this before for this character, and there's something that I need to do first, and it's because, so normally in MNPRX and in Flair, every object has a material. But in this case, because this is an anime character, we have, for example, for the eyes and the mouth, two different materials within the same object, right? So what I'm gonna do here is just save the selection. Let me open up the script editor. Where's the script editor here? I need to find it all the way. There we go. So I just opened the script editor and I'm gonna save the selection. So I'm gonna write here eyes equals commands. You normally don't need to do this, but to save time, I'm gonna do this right now. Select objects with material. As you can see, only these faces are assigned to that material, and that's exactly what I wanna save here. And the same thing for the mouth. I just do mouth and copy and paste this. So, and the reason why I wanted to save this selection in two variables is because to speed up the process, I'm gonna use here a tool called Autoconvert Maya materials. This will automatically convert the Maya materials into Flair or MNPRX materials. So once I click in there, as you can see, most of the materials are fine except the face and the body, which all used to save this, share the same material. So I'm gonna tackle that here since I have these parameters saved. So first of all, I'm gonna separate the skin. Gonna create a new textured material for this. It's black because it doesn't find the texture, but well, it's kind of tough doing everything in one screen. Okay, 1 second. Okay, so I need to add the diffuse texture of this model. Oh, the albedo texture, source images, body diffuse. There we go. And then since we saved this, I can simply say now command select, whoops, and then I go mouth replace equals true, and then I'm gonna add another textured material to that so that we have it there. And now I can call this properly mouth. If you have any questions, guys, while we do this, please let us know. This is supposed to also be like a improvised peer programming / Q&A session. So, and I add here the mouth. There we go. So let me save this scene just in case. So now we have the entire scene with MNPRX materials, and we will have much more data in the AOVs as well. So once I output here, you can see that the AOV target now has the lighting direction in one channel. So as you can see, whenever I change the lighting, the AOV also changes lighting. And we have proper depth as well. And basically any other, oh, sorry, I didn't want to close this. Any other information that we can extract from Maya as well. So if we go here into normals target, you're going to see the normals also. And this is perfect because with this we can do any kind of style that we want, right? And right now we have it connected to Maya, but these AOVs can come from any renderer. That's important to emphasize. So they can come from Arnold, they can come from Mental Ray if you still use that, they can come from V-Ray, they can come from RenderMan, right? It doesn't matter, it's just, at the end of the day, it's images, right? And once we read the images, depending on what kind of post-processing we do on them, it's the same thing. Doesn't matter basically where the images come from, as long as the same data is available. So with that being said, let's convert the color into LAB so that we have proper outlines with that. So LAB is a different color space for those who might be wondering. And this color space, so a color space is, for example, red, green, blue is a color space, right? Which is the color space that our screens mostly illuminate with. Is the streaming still going, Alex?
Yes.
All right, cool. Yeah, I was just seeing weird stuff on my second screen. But anyway, so yeah, RGB is one color space and LAB is another one. LAB is separated into lightness, and then the chromacity is separated into the A and the B channels. And we can easily convert into that by using another shader that is available with Flair. And this shader is going to be here on the transform. Nope, probably on the color. Nope. Let me move this around. And this is going to be in let me just search, and I don't find any.
What are you looking for?
I want to transform from RGB to LAB space.
Transform, I think.
But I think that's like a 2D transform, if I'm not wrong. Yeah, this is scale, rotation, stuff like that.
I saw it at some point.
Yeah, there we go. RGBD to LABD. So
Watercolor?
Underwater color, yeah. So once I load this in, we have this shader here, which I'm gonna call this RGBD, so that we know what it's actually doing. And this one accepts the color from one side and the AOV target that contains the depth. By the way, the depth is in the red channel of the AOV target. And all of these that we're talking, this is available in the Flair user manual. Once you go into AOV's breakdown, here you will have all the different AOV, like all the different images, and what is contained in each channel as well. So you can see the AOV target. In the red channel, we have the depth in Maya units. In the green channel, we have lighting, and in B, we have feature noise, or for velocity target and so forth. So in case you were wondering where these are, they're there. So yeah, let's get in the color target, and let's get in the AOV target. And if we were to output the result of this shader here, we would have, this is how this character looks like in LAB space. As you can see here. And this we blur, and this we take out.
Oh, just could you save the document?
Oh, that's a good idea.
So that, let's see that you see.
So let's save these as outlines. There we go. And it's looking like that because here we're doing a subtraction, but this one should be from this result. There we go. And now we have these outlines, and these outlines have meaning in terms of what they convey. Right, so if we take a look into the shader code here, by the way, before I can explain about this, this one is great to preview and read things quickly, but whenever you're doing shader writing, we recommend you to use a proper shader or like text editor for that. Also because in the case that Flair, since it's in alpha stage, I don't know, crashes, you will still have your code in the text editor, so you're not really losing anything apart from connecting a bunch of nodes together, all right? So, and yes, going back to this, so because we are recognizing or detecting the edges from LAB and depth, we have different kind of edge information. So in the red channel we have lightness, in the green channel or Y we have chromacity, and in the blue channel we have depth edges, so depth-based edges, so that we have this result here. In case you want to single out individual channels, for now what you can do is we have here a debugger shader that will allow you to do this. So once I load the debugger shader and put it at the end of the graph, let me call this debugger. Here we can single out individual channels, right? So this in the red channel is the luminosity edges, and the green channel is the chromacity, and the blue channel should be depth, though I think there's something weird there. Yeah, we'll look into this a bit later. But yeah, in case you want to do that, you can use this. You can even remap values. So in case you want to remap depth, you can also use the debugger for that. You can also see negative values. And yeah, so, or even the alpha channel as well, in case there's any alpha information you want to see. And okay. So we've had edge detection in watercolor, and we use this, however, to darken the edge, not really to create an outline. And this is what we wanted to do in this peer programming and live streaming session. So let's get to it. We're gonna create a new shader node, and now we're gonna use the result from the shader detection to create outlines for this character. But before doing that, I also want to add a background to this character. So I'm gonna create here set, and I'm gonna do a blend alpha. Where is this? Here. And I'm gonna add a color node. This is gonna be white. This is the background. And we're gonna add the color target here into A and the background into B. And then we're gonna pass this into here. So right now, if we were to visualize this one, let's create another output here, just to quickly see this. You're gonna see that we just put in the character on top of white instead of on top of black, based on the alpha value that we have here. This is gonna be something similar like a merge node for those who know about Nuke. We can delete this. What is this, Alex? Do you remember? Ah, this was the first. Yay!
Yep.
And Alex?
Yeah, there was a little flag.
Oh, right. So I need to open Flair again because we had a small crash there. So yeah, Flair is still in its alpha stage, so Alex has been working on a very big rewrite for the beta stage because there was just many things that we wanted to implement that we were seeing, okay, we need to do things differently if we want to have it to be this extensible, right? So yeah, that version is going to be done in the future. Alex is already working on it. I'm just gonna redo quickly what we previously did. Just adding a blend alpha, and adding a color. It's gonna be the background.
So that's why it's important to save often, at least with the alpha, but it's a good idea in general.
So I'm just moving things here and there. I'm getting rid of these nodes and I'm outputting what we previously had. And this was here as well. Okay. So we have the same thing, the color with a background and a merge node. So now we want to take these outlines and add them to the color target, and for that we need to create a new shader. And this is gonna be add outlines, and we go here. So in the left side, this is Visual Studio Code, in case you were wondering. On the left side, we have all the different Flair shaders that we have created so far. And we are going to create new ones. So for this, I'm going to just create a new folder called Outlines. I'm going to move this to the root. Okay, there we go. There it is, outlines. And I'm gonna create a new file, and this is gonna be called addoutlines.glsl. So starting from an empty text file is not like, one can do it for practice, but that's not what I would call a good approach. So what I normally tend to do, and I think Alex does something similar as well, is take a shader that's already been written, just copy and then paste this here and then modify things. So Flair shaders are divided in two parts. The first part defines what we want to pass on to the shader, and the other one is the shader itself, and the shader is here opened with a main function here. By the way, guys, any questions so far? We've talked about a lot of things already, so please let us know. Adele is also in the chat, so she can answer questions more thoroughly, and we can also address them during the live stream. All right, so we have here an input image and a bunch of float uniforms, so like float attributes. This one is a vector2, so a float2 attribute, and we have one image as an output. We can have multiple images as an output as well, which is an advantage of using shaders, but in this case we won't really need that. So I'm going to also get rid of a few things. It's gonna be, I'm gonna call these outline.
Yeah.
Sorry, Alex?
Yeah, no, it's a good idea to always keep like an intensity parameters, because it's usually a kind of parameter that we want.
Yeah.
Just kind of like a scaling factor for the effect.
I agree. So in this case, we don't really need the image to be mirrored in UV space. So I get rid of that. And
yeah, as you can see,
doesn't
you
matter.
can specify sampler parameters directly into the shader, so you don't have to write C++ code for that.
And in
As
case
you can also define some parameters of the user interface that you will see directly in the shader.
So in case you're wondering what is supported in Flair, here in the documentation, we have the inputs outputs. And here you can see what kind of inputs you can write in. For example, a sampler 2D. This is a sampler 2D. And then we have a uniform float, which this one is a uniform float. And then you can have different vectors. And this is the metadata that you can add, and the documentation for that on how that works. Also parameter data as well. So yeah, let's get started with this. So this is going to be, we need two images here. One of them is going to be the color image, and the other one is going to be the outline, right? The one that contains the edges. So we just write here edges. Then we have the outline intensity, which is going to go between 0 and 6, just to add some default values. And we have the main function here. There's a bunch of things that we don't need, so I'm just gonna remove them, like scaling factor. These were all just things that we copied from the other shader. So something very important is to have an output. And in here, for example, to test this as soon as possible, we can create here a vec4. I'm just gonna output a red image here. And then I'm gonna call this vec4 red. And I'm outputting red. So let's test this out on Flair. So we set the shader source. We choose the shader that we just wrote, which is under shaders. I'm working a different directory. 1 second. So yes, outlines needs to be, I'm working from the release version, and this is in the development version, so that's why I need to do this very quickly. And open folder, Flair shaders. Okay, now I'm in the right directory, and this is the shader that we were writing. Alex, do you know how to make the text bigger in Visual Studio Code?
I think it's Control plus or Control with the mouse wheel maybe.
Yeah, no, Control plus works perfectly. And now we can find these outlines, add outlines. So as you can see, our shader is here. We have the first input color, the second input being edges. So we can pass the color here, and the edges that we have here there, and pass this as the output. And for now it's all going to be red, which is what we just defined here. We can change this. For example, I just added one to the green channel, and then I right click reload the shader file, and now we have yellow. And this is how we iterate between one and the other. We just change something in the code and then right click reload the shader file to see the result. So yeah, let's get started. So we have the color and the edges. We need to read them, however. In case you don't know how to read that, the first thing that I would recommend anyone to do is to go to another shader and check how things are done there. That's the easiest way to do it. We're going to use a texture. So we're gonna read here. Color is going to be be a texture, color is the name, and ftext chord. This is going to give us the UVs to read this color texture. In case you're wondering, okay, but where do I get this ftext chord? This can be found here in the documentation as well, under built-in uniforms. So ftext chord, screen space coordinates 0, 0 from the top left corner and 1, 1 for the bottom right corner. So once I have that, I can output here color, for example, and
sorry, Santiago.
Reload the shader. Yes?
Could you restart the live share session, because I've been disconnected, I think. The session ended somehow.
Okay, let me...
No, not the, I mean the live share.
The live sharing session in Visual Studio Code.
In VS Code, yes.
Yeah, let me share with you. There you go, Alex.
Okay.
That way Alex can join us and we can code together as well. So as you can see, I'm just reading the color texture with the specific UV for that pixel. And now we can output it here through that shader. So we need to do the same thing with the edges. Alex, you want to go for it?
Sorry?
Do you want to read the edges texture and output it?
Sure, let's simply... There's considerable lag in this. For the edges, we just do exactly the same here. So there we go. We have both the color and edges as RGBA vectors that we can combine together.
So let's take a look at how these images look like again. So if I look at the edges, we see that most of it's black, and then we have, whenever there's an edge, we have a very bright spot, right? So one example of what we can do is subtract the color, like the edges from the color. So let's try this out. So I go here and write color is going to be equal to, I'm going to do this on every individual channel. What would be better? Yeah, no, I can do this on all of them at the same time. So
we can just do it like this and see what it looks like.
So I'm gonna do the color, the RGB of the color, which in this case is XYZ, minus the edges, whoops, the red channel, and then let's see how that looks like. Oh, you wanted to say, Alex?
Another syntax, if you prefer, you can also write in GLSL RRR to duplicate or replicate 3 times the R coordinate, which is equivalent to this.
So we have a question. Adele is asking, what is the link to the Notion documentation? Let me pass that right away. So you have that on your email, but just in case, I'm copying it here and I'm pasting it there. There you go. So yeah, let's continue. So once we subtract this and put this into the output, then we can reconnect this and reload the shader file, and we have an error. So let's see what that error is about. So we have here in line 19, assignment of incompatible types. We have this. Oh yes, this is because we were assigning a vector 3 into a vector 4, so we need to fix that in order for the shader to work. Once we reload this, you can see here already that we have some funky looking outlines. So, but this doesn't really look very well, so we need to work on that. So one thing about the difference of Gaussians is that we have positive and negative values on the edges. So let me call this here edges, just save just in case. And I'm gonna create here an image shader. I'm gonna assign the debugger to it to debug this together. I'm gonna plug this here and this out there. Debugger. So as you can see here, we can only see the positive values on the screen, right? But with a debugger, you can also visualize the negative values of it. And these are the negative values. And because the difference of Gaussians takes a mathematical difference between two images, there might be negative values, which also can convey very interesting information. For example, in the depth, you will know which outline is the one that's in front and which one is the one from the object of the back, and things like that that can be very useful for when you create your shaders as well. So with this set, whenever we are subtracting this one here, we're actually adding the positive values, basically adding, the negative values to it. So we need to do some absolute value here.
Let's save the graph.
Save the graph. Graph is saved. So just adding outlines here and reload. And now we have much better outlines. Let me keep this on top so that you can see how this looks like. Now these outlines are only based on the luminance, so because we're using the red channel only, so things like here where you have the edge very close to each other, it won't show you the right outline. So we can fix that. First, I also wanted to get rid of the specular highlight on the shirt and on the pants because that looks kind of weird. The way I do it is I go here and disable specularity. Same thing here. Okay, this one was already there. Perfect. So now we don't have any specular highlights that might come in the way. So we have the edges from the luminance. Let's also add edges from the depth information that will allow us to have outlines in these parts here where the luminance is very similar, right? Alex, you want to do this? Alex, you there?
I am.
Okay. Do you want to handle the edges of the depth? Okay.
I don't have access to the graph, so
Okay.
I can't really see the result.
No worries. Then I can.
Yeah. So what edges do we have right now? We have the intensity, the luminance edges, right?
Correct.
So
we have the luminance edges.
So we need to probably modify the input of the difference of Gaussians to take into account the depth, or do we take that?
We already have that in the, because we have this, we plugged here the RGB depth in this node. So we actually have the edges in LAB space, sorry. So we can use the alpha channel of the edges that contains already the depth differences in this case.
Can you show it in the debugger?
In the debugger? Yeah, of course. So I'm just plugging this here, and then in the debugger I visualize the alpha, and whoa, we don't have anything here. No, sorry, it's in the blue channel.
Can you just maybe let's look at the blue channel?
Yes. But this is giving some kind of funky edges. I'm not entirely sure where they come from. This is giving edges from a wrong, yeah, from shading. Let me change something in the shader then. So this is the RGBD to LABD. We compute, we have the depth in the alpha channel. Then we are blurring everything. We are blurring again, and then we have the edges in LAB. Let me just check if the alpha channel of this one is the right one. Yeah, we're not getting any result here. Unless, 1 second. Let me just test something out and make sure it's not the debugger that has a problem there. So I'm gonna say output equals color dot w, and this is gonna be a vec4. So I'm just outputting the alpha channel and see what that looks like. Putting this here, and then I need to reload the shader. So we do have some alpha from the color. I need the edges. Yeah, we still don't have. So I think during the blurring something is lost currently, because when I do this, sorry, into the debugger, and then I output this out. We had the normals target. We need the AOV target. That's why we were getting some weird, very weird data.
Makes sense.
Yeah, that makes sense. So, okay, so now we should have, I just closed what I needed. Guys, in case you have any questions about Flair, about what we're doing, let us know. Will Flair have the non-commercial license to try? Oh, actually, Etienne, there, I sent out an email to participate in Flair, and you can get Flair, of course. You just need to go to Artineering.io Flair. So you just need to go into our website, into Software Flair, and then sign up here. And then we'll pass you a link with the full Flair alpha version. So there's no limitations on resolution or anything. So yeah, make sure to sign up here, and then you can get your hands on Flair. And you can also help us also once we send out the questionnaire for the user study, so that we know what are the most pressing features that you want to have. All right, so let's continue here. So now if I visualize, I don't think this is, something odd. Are you also seeing this, Alex? Okay.
I'm not seeing anything. I'm seeing a black.
Yeah, okay. So I have here the AOVs. This is passed into this channel. Correct, this is the RGB to LABD. We pass this into the debugger instead. This is correct. And then in the end, we have the edges, but we still don't have a result there.
What if you bypass the blur shaders?
Yeah, I'm trying this out.
It's a bad idea. I mean, it won't do anything.
It won't do anything, yeah. I'm just surprised that we have here complete, like alpha doesn't display anything. Anyways, so yeah, we don't have depth right now, but we can get the edges, for example, from the normals target as well. So let's do that. We're going to have an image import, and then we are reading in the normals target in this case. This is going to be normals target. And we can pass this into our add outlines to add the outlines from the normal differences. So for that, we need to create a new input here that is called normals. Once we have the normals, we can read them in as well. Normals. All right. But the thing with the normals is we also need to find the edges of the normals, because it's of no use to have normals without the edges of it. Let me just save this, reload the shader. So these are our current normals in the scene. So let's get to it. We're gonna do the same thing. We're gonna blur them, and then we're gonna extract the edges from that. So I'm gonna copy these nodes, paste them over here. And pass this information into this. So now we have the blurred normals, and we need something similar to what we did here. So I'm just copying and pasting. And we need, this is the blurred one, this is the normal one, and we visualize this. So these are the edges from the normals, right? And we can use this and plug into the outlines, add outline shader. Right now I'm gonna plug in this here as well. So what we have here is we have outlines from the RGBD, so the red, green, and blue channels plus the depth. And then we have outlines from the normals, and we're gonna mix them both to add outlines to this character here. So we go into modifying this shader. And we're gonna do something very similar in this case. We're gonna do color.xyz equals xyz minus apps 3 not edges but normals. And once we have that, we can do the same thing with the green channel. And then we're gonna output the color. So let's see how that looks like. Just gonna output this here, save the graph, and then reload the shader file. And you can see here now we have much more defined normals. So something that we wanted to do is to also add controls to modify these different normals, because as you can see here, we're having normals sometimes from or things that we don't necessarily want to have normals from. So for this is when Flair and Maya can communicate, is amazing to create these kind of things. So let's create first the controls. We go into View, FX Controls, and we're going to create one, which is going to be called Edge Intensity. And this is going to be controlling the edge control target. Let's put it on the red channel. So what this does is this automatically defines the type of control that we will have in Maya to control the style. So if we open here the paint effects, whatever we put in here, we're going to have the tools here. So control the. So whenever I modify something here, the tool in Maya will be there. And this tool will allow us to modify the 3D object and read this in later into the stylization that we have here. So I'm going to create another one called Edge Width into the edge control target as well. But this is going to be the green channel. Control. Alright, so now that we have these two controls, we have these two controls in Maya as well. So we just need to load in the edge control target, which is the one that is going to be modified by our control. We have defined it here. And once we load in, we import the edge target, edge control target. If we were to visualize this, right now it's entirely black, but whenever I select the object, let me just save just in case. Whenever I select an object and go and, for example, decrease the outline intensity in this case, we're not going to see anything because we're painting negative values for now. I'm just going to paint instead positive values for the edge width. And this is going to show that the green channel is being painted on. And we can use these values that we have just defined with this control target to modify the underlying algorithm so that we have a different width of the outline, right? And since this is in object space, this is always going to stick to the animation or to the character itself. So yeah, to visualize the negative values, we can go to the debugger and visualize negative values. You can see here what we painted red before. So just to exemplify this, just gonna paint some more. Decrease. So you can paint your control parameters in 3D space and have them shared in real time with Flair so that you can continue doing stuff. And yeah, let's do something very basic so that this live stream doesn't drag for too long. Are there any questions so far? All right, looking forward to having you testing it, Etienne. So let's continue. So we're going to use the intensity to modify the way the outlines look like. For that, let me output again the result here. There we go. These were our very fast outlines that we created for this character. and we need to modify the add outlines shader. So for this, we're gonna read another image, which is gonna be the edge control. And let me call this, or rather just control. And then I'm gonna read this in. Texture edge control. So now we're reading the edge control, and we need to use this kind of like as a multiplier for these edges. But not only this, we also have here an outline intensity, and we also want to take this into account. So how do we do this? It's very simple. So we have, these are the edges, right? And this is what we are currently using to create these edges. So in order to change this, we can multiply these edges by the outline intensity, for example. We can start with this. So even we can even have different intensities for different types of outlines, so that the luminosity outline would be 1, for example, normals as well, and so forth. I wanted to add one more, which is the chromacity, edges red, green. So just for the sake of understanding this later on, this is the luminance, this is a chromacity, city edges. These are the U, and these are the normals V, because these are in projection space. So let's get to it. The luminance edges, edge luminance, which is a float, is going to be a edges R times the outline intensity for now. And we can do the same thing with the different types of edges. So edge chromacity, edge normals U, we can also combine these two normals, like by getting the distance of them, but for now I'm just gonna keep it like that. Alex, any thoughts on this?
You're using the same outline intensity for now?
Yeah, we could separate the outline intensity, but for now, just to demonstrate, we're gonna keep the same outline intensity. We can share, after we polish this style, we can share it with you guys so that you can see how we end up creating it.
I'm not too sure about the mathematical basis of just like subtracting the values, but I mean, I guess it's fine to get visual results, and it also helps just to demonstrate how we can use these values, even if it's not mathematically.
Yeah, I mean, we could also multiply them, like invert them and multiply them, so that whenever we have something that has a very, like whenever we have an edge, we just reduce the intensity of that pixel instead of just subtracting it. That's another way, or I mean, there's many other ways to do this.
Many ways. I guess the point is more to show which sources of data you can use within the shader and how you can combine them.
Correct. So now we have this here. Let me reload the shader, and now we have a new input, right? For the edge control. However, in the shader code, we have only specified the use with the parameter, not with the edge control yet. But in here, for example, we can already dial in the outline intensity. And of course you can create different types of parameters for different types of outlines so that you have different intensities per different outline. So this is a very subtle outline that looks kind of nice actually. I prefer a subtle outline than a very marked one. So let's use now.
Another way of modifying the outline would be to increase the size of the blur before the difference of gaussians. So you have a wider range for the edges.
So with indeed that's what we do for watercolor. We modify the edge, the kernel of the blurring, so that we have different sizes of edges in this case. But for now, let's keep it like this. Let's add the edge control for the intensity. So we're reading here the edge control. So what's important though is that how we define the edge control is that the intensity is going to be in the red channel, right? So whenever we're reading the edge control, the intensity, right? Let me just float edge intensity is going to be E control the red channel. And we can also use this. So there's different ways to use this. I'm gonna, because edges we're multiplying by the outline intensity, and we can add this to the outline intensity, for example, so that they both work in the same way as to multiply the edge as such. So edge intensity, just gonna copy and paste this. So now that we have this, we can reload the shader file, and we have some very small, let me here just reset the control, set a global, no, I think I
think if you increase the outline intensity, you can see the areas where you painted. I think that's good.
Yeah, I just deleted that though. Okay, because I don't wanna multiply this. I wanna add this. So now that we have that, we can reload the shader. Perfect. Then let me put this a little bit like this. And now I can come here and say, you know what? In this part of the shirt, I want to have a more defined outline. So you can paint this, and as you can see here, we're having a much more defined outline then whenever that becomes there. You can also go here and say, I want to remove the outline in this shoulder here. And we can paint that the same way. Am I decreasing it? Just checking. I think this is not working as intended. So let's check why that is the case. Oh, sorry. Into the debugger, and I need to see the negative values. So I am decreasing this, but the edge intensity is not really Let me try something out just to check. So if I go here and I decrease the edge intensity. I am increasing it in this case. Wait. Getting confused. Okay, let's increase it here. This is working well. Let's decrease it here. It's because we're getting the absolute value here. Okay, then let's move the absolute value up to here instead. So whenever we were getting too negative, we were getting positive again, and then the same thing was happening. So we need to move things a bit around.
So to be clear, edge intensity varies from -1 to the control targets.
Correct, the control targets can be positive and negative. So that's why we're doing this. And as you can see, now we have a white one, so we also need to clamp this value. Since we are doing this, this is subtracting by something very small as well. So let's clamp it to 0. Clamp, oops. In case you're wondering what kind of functions you can use with GLSL, in case you have never written with that, you can go into writing shaders here, into intrinsic functions. And here we have started writing some of the functions that GLSL has, but there's literally a ton of functions. And you can find this, for example, this is a link. This is OpenGL-ES, which is not exactly the same thing that we're using, but most of the functions remain the same. So if I go here to clamp, you find out how the clamp is usually performed. And I believe clamp is... we don't have clamp here. So let's go to this and clamp it. The way this is written is you clamp the value, and then you can write here the 0 and something else. But I just realized I don't want to clamp, I want to use a minimum instead. So the minimum between this value here and 0.
Well, don't you want maximum instead?
So what I'm trying to avoid is having here a double, two minuses that do a plus and push the color towards white, which is what we have here. For now, I'm not too concerned about having colors that are too black, but yeah, in at some point we will need to address that as well.
I think that's the maximum, because if the first term is negative, then minimum of the negative term 0 will be still the negative term. So
you mean writing here max?
Or basically you want to avoid luminance chromaticity, E-luminance chromaticity, and normal UNV to be negative ones, so that you don't
correct
end up adding ones. So yeah, you should.
Oh yes, it would be a max, sorry. But I just realized we're only interested in values from 0 to 1, so we can also just use saturate here. Because
which is a kind of clamp.
Yeah, it's a clamp between 0 and 1, but just for the lazy ones.
I don't think that's a built-in GLSL function, but we have it supported in Flair.
Correct, so that is not built in, but you can find it here on the saturate. Clamps the value between 0 and 1. So we implemented that and provide it with Flair as well. So let me go back here. Just continue saturating this. and saturate here again. And there we go. Now we should have something that behaves the way we want it. So as you can see, whenever I come here and paint the outline out, right, the intensity out, we are removing the outline. Whenever we want to increase the outline, we now have more outline. And since we defined all of these effects from Flair, we also have access to the noise effects here, which is really cool, because in case you don't want to paint every single part or polygon of the body, for example, we can come here and add a procedural control of that. And so you can see some parts now have outline, like here. Some parts don't have any outline, and so forth. So in case you really want to provide outline over color, over depth, over the normals as well, you can even add like noise effects and paint effects for each one of these outlines, right? So that's a flexibility about Flair, is that it literally allows you to create the controls that you need for your production, not from like in MNPRX where you just got what we provided to you, but you couldn't change it, right? So that's a whole different concept. We're opening up the entire stylization framework for you to create your style, literally, and to adapt it on a shot-by-shot basis in case you want to. You can add bloom. We can, for example, save this and import it to watercolor and mix it with watercolor. Maybe that could be something interesting. But yeah, you can do all sorts of mix and match to create really whatever you want to achieve with it. So yeah, that's it for this live streaming session. We will continue a little bit with this, and we'll provide you guys with the graph so that you can play with it and with the shaders as well. In case you have any questions about Flair, please let us know. Reach out to us either through Discord or hit us an email. And yeah, we're here to develop this for you. So we're interested in hearing more about what kind of features you need. All right, Alex, is there anything else you want to say? Alex?
Hello?
Oh, Alex? You.
Yeah, you. Good.
Oh, okay. I was asking if there was anything else you wanted to say.
No, not really. Please try it, and we'll be happy to hear your feedback.
Mm-hmm. Yeah, we'll also be implementing the width control so that when we share this graph with you, you have this kind of outline control for it as well. All right. Thank you very much for tuning in. This video is going to be on YouTube in case you want to rewind and check anything that we have talked so far. And yeah, thanks for joining us, and looking forward to seeing what you end up creating with Flair. All right, guys. See ya. See you, Alex. Thank you for joining.
See ya.